Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to complete RMS current, which is part third video of the alternating current. So what exactly RMS current is? So we will define this and we will derive some of the things, some of the derivations. So for that we need to understand RMS. What is the full form of RMS? Root mean square value of AC. So it is defined as the alternating current over it is defined as the value of AC current over a complete AC over a complete cycle, which would same amount of heat and in a given resistance that is generated by a steady current in the same resistor and in the same time during a complete cycle. Let us take a circuit like this. So this is your circuit and this is your AC source. This is your AC source and there is an resistance. Another circuit is there and this is a DC source, but the resistance are same. This is positive and negative. And the when will flow, so you know that when current will flow, so what will happen? Heat will be generated. Heat will be generated, right? At both the resistance here as well as here. Now if heat, so see here, we observe that the amount of heat generated will be same. Let us suppose here heat generated is 100 joule and here also heat generated 100 joule for the time period of a t. Then the current, amount of current, because it is your steady current, so the amount of current is known as IRMS. Okay, because we cannot tell that what is the amount of current is being used for a full cycle. The uh, the amount of current is like this. So for a full cycle we need to find a current, so that value which will generate same amount of heat as this steady current is generating. So this is referred as IRMS, and we will talk about the full cycle. Now what happens, how to find IRMS? First of all, you need to format, that is IRMS. RMS means root mean square. So first of all you need to do is that square. You need to observe here square of what? Instantaneous current. Here the current is not constant, so the value of current I is equal to I naught sine omega t. So from here you need to find square of I. Let us consider square of the I. Now we need to find square of I. Square of I over a time period of how much? See, amount of current in one cycle is in the time period of this. So we need, this is this is your instantaneous value, but we need an total amount of current. So we need to integrate it over a time of period of 0 t only. Why here we are taking a t? Because it is square. In earlier case what we have done is that only we have taken half cycle, but here we are taking full cycle, because when you are doing anything square, so negative cycle will be also become positive. See here, earlier this cycle, but now it has become like this. Got it? So when you add it, so it won't create a zero value, so that's why we will get a perfect value. So from here we will integrate it. So when you will integrate for a whole one cycle, so you will get a total amount of current. And mean, if you want to create a mean, so 0 to time period t dt. Okay, so after that you have got mean. See, first of all I have done a square, so this value is square. Mean, this when I have divided total time period from 0 to t, so we have got mean. Now root, so just take here as a root. So this value is known as IRMS. This value is known as IRMS. So we will solve this step by step so that you can understand how to solve the IRMS value, and we can get a point, or we can get a final point. Let us do step by step. So first of all, again, I am writing here IRMS. IRMS. This is equal to integration of 0 to time period t I dt, and this overall root divided by time period t, because the integration of time will become a t only, so just I am writing over here only like this. So after that, what should we do? We should put the value. So here we can put a value I. So value of I is I naught sine omega t. Sorry, this was a square. So I naught square sine square omega t into integration from 0 to t dt divided by time period t. From here we got this. Now as we know that sine I naught is your peak value, which is your maximum value, so we can take out I naught from outside by t. I naught square by t, we can take out I naught square by t from here. Now after that we will get sine square omega t. So can we write a sine square omega t as a 1 minus cos omega t? Sorry, this is your cos 2 omega t. Yeah, you should understand or learn this formula. So this is your cos 2 omega t, cos 2 omega t divided by 2 into dt from the time period of 0 to t, and this whole as taken as half or a root. So from here again I naught square by t. So integration of one will be time period t minus cos. Integration of cos is your sine 2 omega t just you take this 2 as outside, so we can put like this 2 omega t by 2 omega from 0 to time period t, and this whole we can take as a bracket half or a root. Now again I am just writing in this direction, so this will be IRMS. Again IRMS is equal to I naught square by 2t, and if you will put limit, so t minus 0 is t minus sine some t sine 2 minus sine 2 omega capital T by 2 omega minus 0 will be 0. Okay, we have put the limit, and this whole uh, as a root. Now we will get omega t. Now just you try to understand what is the value of omega t. So as we know that omega is equal to 2 pi by t, so omega t can be written as 2 pi. So this thing you have to put here. So when we put the values, so let us put the values. So here we will get as a I naught square by 2 pi into t minus sine omega t is equal to 2 pi. So this will be sine 4 pi divided by 2 omega and this whole as a root. So as we know that sine 4 pi is 0, so 2 pi sine 0, sine 2 pi, sine 4 pi is 0, so this will term will become 0, and yeah, this was t, so this was t. Okay, now when it will become 0, so this finally we are getting as I naught is square by 2 only, because t into t will get cancel out, and this whole as we are taking as a root or a half. So finally when we take out root, so what we will get, we will get I naught by root 2. So I naught by root 2. Finally, the value of I naught by root 2, that is equal to I naught divided by 1.414. Or we can also solve this. If we will solve this, so finally IRMS is equal to IRMS is equal to 0.707 I naught. Okay. So if we talk about the percent, so this will be 70.7% of the maximum peak current is the IRMS value. So if you want to represent graphically this graphically let us consider this is your graph, and this is basically a graph like this. Okay, so this is I naught, this is the maximum peak current, this is known as I naught. When we talk about IRMS, so IRMS is equal to 0.707% of I naught. So that is 70% of the I naught. So it will lie nearly this one. So nearly 70%. So if we talk about nearly 70%, so let us see where it can be lie. So it can lie here. So this amount is known as 0.707 I naught. So this value, the value of magnitude of this current is known as RMS value. I hope you have understood this and enjoyed the class. So in next class, I will also discuss more about other topics. So be in touch with us so that you can understand. So our today's point of discussion was only IRMS. So thank you for watching video.